Alright guys, now let's see how to work with problems which can be derived from this formula, that is sine of a plus b, which is sine a cos b and cos a sine b. We do not understand this when we see the problem only, right? So let's say if at all I have to just put this guy on the other side, it goes like what? A plus b is equal to sine inverse of sine a cos b plus cos a sine b, yes. And let's say this was my question. Okay, that's how it looks like. So sine inverse of, I have two terms. There's a plus sign also. And can I basically convert that problem to this? See, in fact, that problem is generated because of this formula only. And see how we can create sine a cos b cos a sine b inside. This whole thing has to become what? According to our first logic, this has to become sine of something so that I can cancel out this sine inverse with sine of whatever comes inside. This can happen if at all I have a sine a cos b cos a sine b. It looks like what? Sine of a plus b. This sine is what I'm looking for. Let's go ahead, and before I can continue with this, I would like you to keep this in mind, strongly keep this in mind. Whenever I have 1 plus x and a root of 1 minus x, something like this, alright, connected like this, always the x part is substituted as cos 2 theta, and in fact it can prove out to be very helpful if you remember this. Whether you have it in division or you have 1 plus x plus or minus 1 minus x, whatever it is, when you have a root and you have 1 plus x and 1 minus x, or 1 plus x squared and like this square, whatever, if this design is seen, right, it's always convenient to write whatever x squared or x comes as cos 2 theta. It works really good and it can solve a lot of problems. We can see this as we practice a couple of problems, alright? But I want you guys to keep in mind, whenever these guys come together, this 1 plus x squared or x cubed, whatever it is, okay, then I'll take this guy x cubed as cos 2 theta, whatever is here inside as cos 2 theta. Keep this in mind. I'll keep reminding you with this substitution in a couple of next videos. See, if I can see this problem also has got root of 1 plus x and 1 minus x, so I take x as cos 2 theta. Why we'll understand a little later. See what happens here. So I can write, if this is my question, y is equal to sine inverse of half, and this guy looks like root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta. There are two formulas, if you guys remember, from cos 2 theta. If not, let's just work on it. If you have 1 minus cos 2 theta, it is, the answer is 2 sine squared theta, and 1 plus cos 2 theta is given as 2 cos squared theta. Okay, keep this in mind. Very important formulas which are derived from cos 2 theta formulas. All right, keep that in mind. Pretty important formulas. All right, now based on this, if I can see, this guy can be written as what? The second stuff, that is sine inverse of half is here. Half is for both them, so root of, I can write 1 plus cos theta as 2 cos squared theta plus this is written as 2 sine squared theta. Yes, this half has to be multiplied with these guys later inside. So sine inverse of, I can say half, and I can write this guy as what? Root 2 cos theta plus root 2 sine theta. See what's happening now. I can see that sine inverse is still here, and a half, and root 2 I can take common out. I like cos theta plus sine theta is what I have. Very nice. Now can I do something with these two guys? Let's check. I can write it as y is sine inverse of, I can write this denominator 2 as root 2 into root 2, alright, and 1 and root 2 here. That's it, into cos theta plus sine theta remains the same. Now what happens? I can cancel one of them. So it is sine inverse of 1 by root 2 into cos theta plus sine theta. Okay, that's what I get. Can I make that guy look more like this? Now see, I wanted sine a cos b cos a sine b, but I still have only one cos theta and sine theta. I need two of this. With cos theta I need sine a or sine theta or something, sine with something. So can I multiply this root 2 1 by root 2, both of them? That is sine inverse of, I can write 1 by root 2 into cos theta plus 1 by root 2 into sine theta. Yes, now it looks like 1 2 3 4 guys at least we have, right? If I would had a sine of something into cos theta plus cos of something into sin theta, that would have looked like sin A cos B cos of sin B. And I also know that sin 45 is what? What is sin 45? Or sin pi by 4. Pi by 4 is actually 1 by root 2. And cos pi by 4 is also 1 by root 2. So I can see that I can substitute 1 by root 2 as cos pi by 4 here. So it looks like sin inverse of what? Sin pi by 4 into cos theta plus cos pi by 4 into sin theta. Now it looks more like sin A cos B cos sin B, where A is pi by 4 and B is theta. So what happens to my problem? Y is equal to sin inverse of sin pi by 4 plus theta. Now I can see I can cancel this, guys. So my intention or my motive or my thought process is, when I have a sin inverse outside, I should make sure this has to become sine somehow so that I can cancel the sin inverse on that side. So for that, I just took this there. I told you how we can remember this is whenever you have a square root and 1 plus x, 1 minus x coming together, maybe in numerator, denominator, or next to each other, whatever it is very convenient to take x as cos 2 theta, and that formula is those two formulas here, these guys, very important formulas. Keep that in mind. All right. Let's come back to the problem. I can see that y is equal to pi by 4 plus theta is what my question is now. Now who's theta? From here is where I get theta from. Alright, so can I put cos on the other side? Yes, I get 2 theta is cos inverse of x, and theta is actually half into cos inverse of x. This comes from this substitution. Can I put it back there? I'll just write here. I don't want space out there. So y is equal to pi by 4 plus, instead of theta I would write half cos inverse of x. Now we differentiate this guy now. Differentiation is only so much. This is 0 plus half is a constant. This is minus 1 by root of 1 minus x squared. Okay, that's my answer. I can write minus half into root of 1 minus x squared would be the answer of my question. It's a very important problem, basically, this guy. And it is based from this particular formula. That's it. Alright, similarly you can have cos of a plus b, that is cos a cos b sin a sin b, and you need to make something like this only. Alright, so maybe there you will get cos here, cos inverse, and you should make this guy look like a cos a cos b and cos a cos b sin a sin b, and reduce it to cos of a plus b or a minus b, and just cancel the cos inverse and the cos, and that's how it works. Alright, I hope you get this, and let's go ahead with the next type of problems and try working on it.